Hi, we are Team 9. Today, I'm very excited to show you the implementation and the demo for our newly developed osmosis application. Let's first start our virtual machine, Team 9. As you can see, it's already running. And this is our virtual machine. And here is the instruction to run our application. We can open this file. And by following this the instruction, we can open the application folder and then open the terminal. Here we need to start our Spring Boot. We actually use Spring Boot for Java application. As you can see, the Spring Boot is started. So then we can open the Google Chrome web browser by entering this address. Okay, so our application is started. This is the first page for our user interface. It allows us to input the test case file. So we firstly use the test case tool for to test our application that we can submit. Okay, this is the main user interface for our simulation application. So as you can see, there are 3 buttons: Next, Stop, Fast Forward. This button allow the user to control the pace of the simulation. And the picture on the right shows the the map, long map. As you can see, the size is for the map is 6 by 4, and there are 4 craters and 4 mowers, and the initial location for each mower are also the charging pad. And also we have 2 tables here. The table on the top shows the long map summary, such as the number of the initial grass, and how many grass has been cutted, how many grass left, and the numbers of turns. And the table on the bottom shows the mower state for each mower, and if the mower is crash or stall, it will show here, and the energy level and numbers of the stalls. Okay, then we can start our application by using Nest. As you can see, the first mower has been selected, and it performs scan action. And we can continue to press Nest. And as you can see, the mower from mower 1 to mower 4, they all perform scan action. So here I wanted to introduce how our design allow a mower to smartly choose its next action so that mowers can move more efficiently to cut the grass. So the logic is we firstly check if any surrounding square for a mower is unknown. If there is an unknown square, then the mower will perform the scan action. So that's why you can see in the first turn, all the mowers perform scan action. And then if all the surrounding square are known, at the same time, there is a grass square in the surrounding, then the mower will move to that grass square, then cut it. So if we continue to press Nest, so actually the mower 1 will cut the grass on its right. So then if the first 2 conditions are not true, which means the surrounding of this mower has no grass, containing only empty crater, fence, or other mower. So in this situation, we will use a breadth first search algorithm to find a path to the closest grass square or unknown square, so that a mower can use this shortest path to find this grass or unknown square. So we design our application in a very smart way so that no mowers will crash or collide with other mower, and all the grass will be cut efficiently. So we can prove this by continue to press Nest. You can see the updated information on the map. Also, the table information also updated. And at the same time, the report has been output on the terminal. Almost there. Dust grass. Okay, the last grass square has been cutted, and this is the last nest. And the simulation, you see, the simulation is terminated, and the final report has been output in the terminal. As you can see, there are 24 total square on the map, and 20 grass square, and all of them has been cutted, and the total numbers of turns are 11. And also you see from the map, the map, all the grass has been cutted, and from the table you can see there are no mowers. All the mowers have active, and no mowers has been crushed or stored, and they still have energy left. Okay, then we can test the other two buttons, stop and fast forward. We just need to reload the application. Also use the same test case. Then we can actually use fast forward to run the application. You can see the mower is automatically selected and perform the action. Okay, the simulation terminated, and you can see from the terminal it output the same result, and all the grass has been cutted. Now we can test the stop button. And what we can do, we can use fast forward to run the simulation. That we can stop any time, and the simulation will terminate, and the final report will print out to show the current state of simulation. I can stop here. Then simulation stopped. As you can see, the report for current state has been output. As you can see, only 18 grass has been cutted, and the total number of turns is 9 for current state. Okay, so I also want to test our application, use another test case, which is test case 8. This test case has a much larger map with more mowers craters. As you can see, there are six mowers and 42 craters. I want to use this case to show you that in our simulation, how different mowers communicate to each other and how our mower are charged. So as you can see, the 6 mowers are really close to each other at first. And so the logic for our mower communication is that in our design, if a mower scans another mower in its surroundings, and then these 2 mowers will share their map information by merging their maps. So after merging their map, they will use the same merged map for future simulation. So in this way, if one of the mower knows its absolute location on the map, so the other mower will also know its location because that they actually use the same map. So for example, if the mower 1 scan another mower like mower 2, and then they will actually merge their map and use the same map in the future. So okay, we can So the logic for our mower charging operation is that in our design, whenever 1 mower's energy level is lower than the half of its maximum energy unit, the priority of this mower's next action is to move to the charging pad if the charging pad is in its surroundings. So if no charging pad in its surrounding currently, it will continue its original move until it finds a charging pad in its surroundings, so that it will move to the charging pad and be fully charged. So actually, we can prove this by click Next to start our application for this test case. As you can see, the mower one perform scan action. Actually, in its surroundings, there are 3 other mowers. So the result is like mower 3 charge because the mower 3 is still on the charging pad. That's why the result shows like a mower 3 charged. If the mower 3 move to other location and no longer is in the surrounding for the mower 1, it will only show mower 3. So yeah, we can press Next to confirm this. As you can see, the 6 mower all have been selected in the first turn, one by one in a sequence. It all performs scan action for the first turn. Then they start to move. Each mower has to move to new location to cut grass. Okay, it could be very slow to use Next button. We can use the fast forward button to run the simulation faster. You can see the simulation status through this map, and also the table information is simultaneously updated, and also in the terminal, it will output the report. We can actually stop the simulation at any time, but I don't want to stop now. Okay, almost there. Okay, simulation terminated, and the final report has been output. And as you can see, there are 150 total squares on the map. There are 108 grass on the map, and all of them has been cutted. And the total number of turns is 48. This number is far less than the test case requirement 300. So from the map, you can also see all the grass has been cutted. There's and the table shows that there are no more. All the mowers are active, and they still have energy left. So this is proof that our system can allow the mower run efficiently to cut all the grass on the lawn without any crash, stall, and collision. Okay, thank you very much. And I will finally use the last test case to prove that our system is working efficiently. So, but that's all for me. Thank you very much.